Hello, everybody. Thank you so much for coming. I'm just going to start sharing my presentation. Okay, how's that looking?
Looks great.
Great. Thank you, everybody, for coming on this chilly evening. I hope everybody's warm enough and feeling relaxed. It's really lovely to see old faces and new faces too, old friends and new friends, rather. Thank you so much to Everybody Arts. It's such a treat to be able to do this. And I've been wanting to bring these speakers together for a long time, so I'm really, really excited about this. Yes, as I say, I'm so excited to have both Anik and Miranda here to bring together these different perspectives of how we see our world from a cosmic perspective. I've been really lucky to get to know both Anik and Miranda over the past year and had the most amazing conversations, so it's very exciting. I am an artist and curator, and I have a BA in Fine Art from Middlesex University and an MA in Art and Science from Central St Martin's, and I graduated from my MA in 2013. I'm going to share a brief overview of my practice and then move on to Earth, a Cosmic Spectacle. As Sammy said, I grew up in Aotearoa, New Zealand. I grew up in a small city called Dunedin in the south of South Island. And I also spent a lot of time in large mountainous landscapes with very low population density and huge imposing landscapes and very dark skies. And in between that and living in Margate, where I live now, I lived in different cities in England, but predominantly in London for 15 years, which is very important for my practice, which I'll talk a little bit about. There are three central strands to my practice: Earth, astronomy, and light. Earth being our relationship to Earth's, the deep time history and future of Earth's environments and species, and astronomy, our scientific pursuit to unravel the mysteries of the night sky, and light. Light is a symbol of how humanity has understood Earth and space throughout history. Throughout my artistic and curatorial practice, I see my life experience divided into two distinct parts, light and dark. Light being the first half, living under the dark skies of Aotearoa, New Zealand, and being able to see the Earth as a planetary landscape. And the second, under heavily light polluted skies in London in 15 years, where a cosmic relationship was much harder to grasp. Without both of these differing experiences of skyscape, dark skies may not have become so important to my art practice. I'm interested in if light pollution is changing our fundamental understanding of being part of Earth's ecosystem and part of the cosmos. Oops. As Sammy mentioned, Earth a Cosmic Spectacle is an ongoing project that I'm hoping to do for the rest of my career. I was really lucky to start this project in 2024 with Tuhura Otago Museum with Dr. Ian Griffin, who's an astronomer and also the director of the museum. The museum is a museum of natural history, which I used to visit a lot when I was a child as well. And there was also incredible sort of science area where you got to see lots of light installations. And I think that's also fed directly into my practice. But it was very exciting to me to be able to start this project in the place where I started to learn about Earth and space, and that is Dunedin. The second iteration has been a really wonderful further step into this darkness, I guess, thinking about how we relate to the cosmos with the Institute of Astronomy and with Everybody Arts, who's been such a fabulous and supportive partner in this project. What I'm working on at the moment is another chapter with Art Gene and also with University College Dublin and Mayo Dark Skies. At UCD, I'm going to be working with the Earth Institute and the Centre for Space, which is lots of scientists who work in earth sciences and astronomy. So it's very exciting. My exhibition at Everybody Arts explores our world through photography, sound, and drawn and written perspectives. It's a huge privilege as an artist to have the privilege of time, to visit different landscapes and ecosystems and consider how we relate to them or how we feel about them. The presence of deep time is everywhere we look. Our atmosphere, our landscapes, our own senses, and all the lives that live within Earth's ecosystems are the results of billions of years of time passing moment by moment, day by day. The trillions of sunrises and sunsets and trillions upon trillions of interactions between long past individuals, both human and non-human, shaped the world we have around us right this moment. Just as we are shaping the world for individuals today and for millions of years in the future. Our ecosystems weren't inevitable. This world we know is the result of chance over billions of years. One geologist described it as the result of rolling a 6 on a dice continuously since the first moments of the universe. Early in the project, I spent time within the landscapes near Halifax. I was struck by the huge, imposing rock faces jutting out over the hills, reminding us of our own relationship or connection to deep time. I tried to imagine what these valleys would have looked like at other points in its long history. But what do we mean by deep time? Deep time is a concept of geological time that spans billions of years, far beyond the scale of human experience. This can be a really hard concept to make seem real, and it's much easier to imagine huge blocks of time passing as coloured timelines in a textbook. So how can we better see this evidence of deep time that is in every surface we touch, every breath we take, every thought we have? I believe it is by placing ourselves within these scales of time, by understanding our own scientific cosmic origins and the evolutionary journey of species and environments that have been required to create this moment today. I believe that once we open this window within our thinking, it's much harder to take any part of Earth for granted. In preparation for this talk, I was talking to Anik about how small moments can change the way we see the world. I had been thinking about what those moments have been for me over my lifetime. Many seemingly insignificant moments have actually been significant moments that have been completely perspective changing and have added another layer of reverence that I have for the world that we live in. These moments have often included witnessing a few seconds of another creature's life against my own thoughts of cosmic timeframes. Many years ago, I was photographing the night sky in the Lake District, and I had stayed up very late to watch the moon rise. I took my camera outside and waited for the moon to rise over the crest of a hill. I was in a remote area with little light pollution to speak of. As I stood and waited, looking at the cosmos, there were some unfamiliar sounds of creatures nearby. In the pitch black, I didn't really have any idea what they could be. I waited patiently, knowing that in the UK, there's not that many things that are very dangerous. Not many parts of the animal kingdom, anyway. As the moon rose and my eyes adjusted to this new source of light, I saw a group of herdwick sheep standing just a few meters from me, behind a wooden fence, looking in my direction with their incredible reflective eyes. I had a deep realization that these magnificent animals were sharing their brief moment of time in the cosmos with me, and I was sharing mine with them. We were all under the same starry sky in the same moment of Earth's history together. I've had several of these profound moments over my life, just a small handful, and they've often been under dark skies. I feel that this cosmic context reframes how we experience the encounter, and this shapes the way that I see all other life on Earth. the many layers of life that are interwoven to create the world around us, reminds me how special each moment of our lives are, as well as the moments of lives of other people and other creatures. If we look using our knowledge of the scales of time that have been required to create every layer of our world, every interaction, every flutter of a wing, every conversation can be understood to have been carved out over billions of years. My question is light pollution a barrier of light, visually separating us from the cosmos, disconnecting us from this knowledge, or the sense of wonder that we might have about our own planet? How can we understand our planet with such awe as we might have for an extraterrestrial world? As one astronomer in my project mentioned, imagine if we heard music on another planet. Or imagine the wonder we might feel if scientists do find traces of bacteria or viruses or another type of life or even an atmosphere on a faraway world. Yet here we are on a planet that is outer space to everywhere else in the universe. And unfortunately, we're witnessing and experiencing the degradation of life on this planet. Earth, a Cosmic Spectacle, is a cumulative project of gathering thoughts and layers of images and sound in response to this changing planet. I hope that what I collect from now and into the future will act as a time capsule of knowledge of what we collectively understood this immensely or cosmically important moment to be. In the first chapter of the project that I mentioned that I began in Aotearoa, New Zealand, I began with 10 images that were displayed at Te Huru Otago Museum. And this second chapter has an additional 9 images, and they are all interlinked with each other or mixed up, so they're not displayed as per chapter. I create these images by taking many photographs in different landscapes and of different skies and digitally layering and manipulating them together. The intention behind the photographic works is to bring together different scales of time. The first being the long and slow development of Earth as a planet from the first moments of the universe, with the second being the slow evolutionary processes of life on Earth alongside the brief moment of an existence, whether an insect, a bird, a tree, or a human being. I hope that the images invite familiarity, but also distance, with an emphasis that these landscapes and environments do not belong to humanity. They have been here long before us and will surely outlive our species by billions of years. The soundscape is also a cumulative idea. In this exhibition, as you enter into one of the doors, you begin to hear the sound of birdsong, which I recorded in Aotearoa in New Zealand, in the place called Purukanui that I was staying in for the first chapter of the project. And this aspect of the sound brings this idea of Earth to the forefront and the life that lives within Earth's ecosystems. And then the second element of the sound piece was recorded and made using field recordings from Calderdale. And these two parts of the soundscape come together and are called the weight of time. They interact with each other as you walk around the space, with one becoming more prominent as you move from one space to the other. The constant rhythm of the second element, recorded in Calderdale, reminds us of the constants of cosmic time, that this moment is just one of an unfathomable number that will stretch far into the distance, far beyond our lifetimes, beyond humanity, our planet, and the solar system. I developed this project in part because I felt that scientists who have this knowledge of the long periods of time that have been required to create life on Earth must feel hugely burdened by this knowledge in the face of the climate crisis. I have worked with geologists, biologists, and astronomers to think through their particular mode of knowledge or research, to think about how it shapes how they think about the climate crisis. I've often wondered, how can you have this kind of expertise, this relationship to astronomy or the deep time history of Earth, and still be a person that's part of normal society that's learning about the climate crisis as well. After the conversations that I had with each scientist, I give them an envelope with instructions and a blank card to fill in whilst looking under the night sky. And the question the scientists were asked was, how does your knowledge of the scales of time and the 13.8 billion year concatenation of astronomical and Earth-based events required to create Earth in all its biodiversity help to shape your understanding of the significance of the climate crisis? I wanted to give these scientists the opportunity to share how they feel about what they're seeing and what they understand through a private letter not attached to their name or research. Young people and members of the community have also contributed a huge amount to this project. And that includes a really wonderful group of people who came to do workshops at Everybody Arts as well. Instead of thinking specifically about the climate crisis with this group of people, I wanted them to consider the wonder of Earth. So they were given a slightly different activity, but they were also given an envelope and a blank card and were asked to write or draw their response whilst being under the dark skies, looking out into the cosmos and thinking about what we'd talked about. What I asked them to do was to look into the dark skies above you, listen to the sounds of the environment all around you, think about your place within Earth's ecosystem and where Earth fits into the solar system and the galaxy. Think about the darkness around our Milky Way and the distance to the next galaxy. Close your eyes and imagine seeing Earth from a great distance. Think about the colors and all the human and non-human life that has lived and lives within all of Earth's environments. How would you describe Earth from this perspective? The outside walls of the exhibition are filled with over 90 responses. The scientists and community responses are intentionally mixed together. To me, they seem in deep conversation with both the photographic works and the sound pieces, and I treasure every response. And I love encouraging people to think more deeply about their own place in the world and Earth's place in the cosmos. The more I understand about the complexities of every part of our environment and how events over the history of the universe since the very beginning have helped to shape the world that we have around us, the more I feel that there is something hugely missing between how our species is interacting with this planet and the cosmic significance of life on Earth. My years of looking out into the stars have taught me to find comfort in the scales of time and distance in the universe. The great enveloping cosmic dark is both the history and the future of the particles that make up my body in Earth's landscapes. Having a consciousness about this great cosmic cycle of life, death, and regeneration can help us to understand the significance of Earth and therefore the significance of the climate crisis. What can dark skies teach us? Or rather, what might light pollution do to our understanding of the cosmic significance of life on Earth? Throughout human history, human beings have relied on the movements of stars, our moon, and planets for life-sustaining things like farming, navigation, knowledge building, and cultural ways of making sense of our place on Earth and within the universe. How different would humanity be if our eyes didn't develop in a way that meant that we could see starlight? If we think about each creature and each ecosystem as the successful result of 3.7 billion years of evolutionary history, only made possible by the concatenation of events across the universe's entire 13.8 billion year history, doesn't that make each of us in each form of life incredibly precious? Thank you very much for listening, and I'm so pleased to pass you over to the first of our wonderful speakers, Anik.
Thank you, Louise. That was such a lovely insight into your work. So, Anik, next. Ugh. Dr. Anik Halder was born and raised in India. After graduating from high school, he moved to Germany to study physics in Bremen and later completed his MSc and PhD in astrophysics in Munich. At various stages of his studies, Anik worked as a tutor, research assistant, and software developer. After receiving his PhD, he joined the Institute of Astronomy and Jesus College in Cambridge as a postdoctoral research associate in 2024. Anik's research focuses on understanding the large-scale structure of the cosmos using surveys that map the distribution of millions of galaxies. He works at the interface of theory and observation, and his research spans galaxy formation and evolution, gravitational lensing cosmology, and the inference of physical properties of galaxies from large imaging datasets. Anik, it's a pleasure to have you. I'll hand over to you now.
Oh, he's still muted, Anik.
Can you hear me now? Yeah.
Okay.
Thank you for having me, and it's a great pleasure to share this evening with all of you. As Sammy said, I work as an astrophysicist on specifically on the large scale structure of the universe, studying the universe on very large scales, larger than the scales which we can comprehend in everyday life. And in this image that I have on the slide, which I'll explain in a bit, is one of the deep images taken by the JWST Space Telescope that you might have heard of, where every object you see is a galaxy being a collection of hundreds of billions of stars. So in each of these, there are hundreds of billions of stars, and these are some of the uh, oldest objects we have seen in the universe. It's almost possibly more than 13 billion years old, some of the objects that you see here. So in this brief presentation, I want to just quickly walk you through the cosmic timeline, just so that we can appreciate um, where we are at this. We find ourselves to be at this moment in time. So, um, as we understand, our universe is 13.8 billion years old, and here this is a picture that for me sets the context of, if you think of time going along from left to right, there were several epochs that spanned key incidents in the history of our universe. The very origin of our universe, we call that the Big Bang picture, where I'll speak about that in very shortly. And um, then came the formation of the first stars, the first galaxies, and the collection of them to form galaxy clusters. Then the formation of the sun and the solar system and our Earth, 9 billion years since the Big Bang. And then finally, we find ourselves here today, 13.8 billion years later, looking back onto, like, with our telescopes at all the structure that we see out there in the universe. So let's start with the beginning. As we understand, our current scientific theories, which we have big evidence for, is the so-called Big Bang picture. The idea is that all that we see, if you think of all the stars, galaxies, and everything, all the matter, if you condense them back to a single kind of point, if you will, um, the universe was that at the very beginning. Here it's a movie trying to an artist's description of showing that everything was in a very dense state, very hot state, and then suddenly it started expanding rapidly, like dramatically, in the fraction of a second. It expanded from the size, which was way smaller than the size of a proton, to the size of a grapefruit. So this is actually um, spanning many orders of magnitude. And at the very beginning, the universe was so hot that you couldn't, like, all the light and everything that was there, it was like an um, opaque environment. Light would go and scatter off very quickly. There would be no time for light to travel a lot of distance. So it would be very dense initially. But then the universe, as it expanded, it started to cool down. Yeah. And as it started to cool down, the photons, which were the light particles, if you will, that were there, they started to lose energy, and the number of interactions they had with the usual particles like protons and electrons, they kind of went down, and hence the first atoms like the hydrogen atoms, like when protons and electrons could come together, they could form. And this happened over the span of like 380,000 years after the Big Bang. We have very good evidence for this based on atomic physics that we study in school, and theories of quantum mechanics. Um, and then, so at the very 380,000 years after the Big Bang, the universe had cooled down enough for the first atoms to form, and the photons, which were previously interacting with all the particles, they could actually escape. They could free stream, we call it. They could just free stream out, and that light from 380,000 years after the Big Bang, we um, also receive essentially today in not the optical regime that in which we see, but in the so-called microwave regime of the electromagnetic spectrum. We call that the cosmic microwave background. Essentially, wherever we look, this is an image of the whole celestial sphere. If you point your telescope in the microwave range, you'd see um, the light coming from 380,000 years after the Big Bang, which has been traveling ever since to us. And that was because the first atoms had formed and the photons could then freely stream through. Um, it looks very homogeneous on the sky, but then you see this specific pattern where you see tiny regions which are um, a bit more color coded here in yellow or red. A bit these reflect a bit underdense regions. The ones in blue are a bit overdense regions. These were regions where there was a bit more matter and a bit less matter in the very early universe. And what essentially happens is in these regions, um, we start to see the formation of the first objects. So uh, early on, 380,000 years after the Big Bang, the universe just has hydrogen atoms, and these hydrogen atoms start to come together in regions where there's a bit more matter uh, being attracted together by gravity, the forces of gravity. And that's starting to bring hydrogen together. They're coming and forming clumps, and then starting fusion in order to which is the process which drives uh, what makes a star shine. And these were the formation of the first stars, and this happened almost 100 to 200 million years after the Big Bang. So this and uh, these stars, which were at the the first stars we had, they were very massive, way more massive than our sun, maybe 10 to 20 times or 100 times more massive than our sun. Um, and what was happening was that these stars, they were fusing the primordial hydrogen we had to make the heavier elements that we find everywhere in all around us, like carbon, oxygen. These were not there at the beginning. Initially, there was only hydrogen, but then that was being fused by these massive stars, and they creating these heavier elements. And then finally, these massive stars, they were ending their lives in once their fuel had run out in huge explosions. We call them supernova explosion. And they were spreading these heavy elements out there into the environment. So the stuff we are made of, these were uh, the 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 elements like carbon, oxygen, nitrogen. These were all formed in the moments of a dying star and the death of those massive young stars. There's a saying that those stars died because we could live, and that was because these stars they fuse these heavier elements. After that, So we are now talking about 200 million years into the universe, and here this process of formation of young stars is happening all over the cosmos, everywhere. Here, this is a simulation in where you see different regions of space where young stars are forming, and they are coming together, attracted by forces of gravity to form galaxies, which are just collections of stars, and and these galaxies, they are colliding, merging together, and over time, and they are forming regions clumped together, which we call galaxy clusters. And inside each galaxy, these young stars, they are dying, they are creating these supernova explosions, which is enriching the environment around it with these heavier elements, which constitutes our life today, and the environment all around us today. These were all being formed at that moment of time when these stars were dying, and then there were new stars being formed in this environment, and this process of um, uh, fusing hydrogen, creating heavier elements. This was going on and on for billions and billions of years, and so this in this whole time, by the way, our universe is expanding. So what this means is that initially the interactions which were very frequent, they are slowly starting to, like those interactions are becoming l- less frequent, and mergers are becoming uh, more rare, if you will. But the process of stars locally being formed, that's keeping on going, that's happening, and it still happens to this day in our galaxy. So in this simulation, if you will, we have each object here is now showing a galaxy which is thousands of light years across. And one such galaxy is ours, which we call the Milky Way. And that's almost 13.6 billion years old, almost as old as our universe, which is a collection of almost 200 billion um, billion stars. And now let's just try to understand how our sun and the planets around it came to be. So in such a galaxy, in every galaxy, there were molecular hydrogen clouds. Here, another simulation where you see a clump of hydrogen molecular gas which is coming together under forces of gravity. And and a new star is forming. It's a protostar is forming. Hydrogen is being fused and ignited to form helium, and a protostar has formed, which is surrounded by a disk. And this disk is what we call the protoplanetary disk, where material is accreting around. Material is coming together to form newer objects in all around the star, which we call protoplanets or planetesimals. And over time, these planetesimals are clearing their orbits, they are gathering all the material, and they are forming the planets that we come to know of today. So this is how our solar system, with all its planets, formed. And this is the case for any planetary system out there in any galaxy. This is our current understanding of how planets form. And this is our solar system is almost 4.6 billion years old. So it was formed almost 9 billion years after the Big Bang. Um, and yeah, so finally we have our Earth, which is such a planet around such a star in one typical galaxy. And when conditions became calm, when the the solar system calmed down, less bombardment and interactions, the orbits had cleared, conditions became favorable such that our Earth could hold on to an atmosphere. Maybe water was brought in by asteroids or so which were hitting our planet, and then conditions were favorable such that life could emerge, single-celled organisms or so, almost 4 billion or 3.7 billion years ago. So that's essentially wrapping up our cosmic timeline. So this is the picture I showed you before, where we just covered that we had this initial phase of the rapid expansion of the universe, which we call the Big Bang, when all the particles and such were created. And through that, it set the stage of the formation of the first stars, and then 1 billion years later, of the first galaxies, 9 billion years later, our solar system, and finally here we are on Earth, on a rocky planet around our solar system, where, and funnily, that's the only planet on which we know life exists. Yeah, so I think with that, I'll close here. Thank you.
Thank you so much, Anik. That was really interesting. And as I'm sure to most people here, completely new. It's fantastic. Learned a lot this evening. We're just going to take a 5-minute comfort break now. So we'll start again sort of just after 1:45, where we'll move to Miranda's presentation. I think most people are back. Lovely. So welcome back, everyone, for the second half. Just a reminder, please do keep your questions till the end, the Q&A, where we're really happy to hear your thoughts. And if you're happy to keep your camera on, please do. But just be aware that the recording's going on. But please do keep yourself muted unless you're speaking. So it's my pleasure to introduce our final speaker, Miranda Lowe. Miranda Lowe CBE is a principal curator, natural historian, and marine invertebrate specialist at the Natural History Museum, London. She has a deep interest in the politics of natural history display of both fauna and flora, the role that art, science, and museums play in our understanding of the natural world. Miranda was awarded a place on Radio 4 BBC Women's Hour Power List 2020 Our Planet, as a woman whose work is making a significant positive contribution to the environment and the sustainability of our planet, and also received the Society for the History of Natural History's President's Award 2021. She's the chair of the arts organisation called Culture and co-founder of Museum Detox, a network for people of colour who work in museums, galleries, libraries, archives, and the heritage sector. It's a pleasure to have you here, Miranda, especially after you've had such a long day. So thank you very much. I can't wait to hear your talk now.
Okay, well, welcome everyone, and yeah, apologies for lateness, but as I was saying to Anik, the stars were not quite aligned, but hopefully it will all come together, in one big evolved planet. So I'm going to actually hopefully complement what you've just heard earlier on in terms of well, this image here is very beautiful. It's showing many different species of corals. So I'm a marine invertebrate specialist. The Natural History Museum has a space exhibition that's on, and it's entitled "Space: Could Life Exist Beyond Earth?" And within that exhibition, it has a lot of animal groups or animals that I actually look at, some of them known as extremophiles. But the reason why they're in the space exhibition, because we have this famous phrase that we know more about outer space than we do in terms of deep ocean science.
Sorry.
Perfect. Right. There's always something that happens with tech, isn't there?
I know.
Back to you, Miranda.
Right. So yes. So I'm going to. So I was talking about the phrase, the classic phrase, we know more about outer space than the deep dark ocean. So I'm going to talk to you a little bit about some of the animals that exist or coexist alongside one another in the deep dark ocean. Another area, another form of space, to think about it. And looking at these corals here, the different dynamics of them, they're like, different parts of the planets that we look at in outer space, the craters. You could look at some of these in a similar way. But I'm going to show you lots of pretty pictures. So as I said with this one, so we're going to go deeper into the ocean for some of these animals. And as you can see here, this is a close-up of a brain coral. And you could sort of look at that in terms of the craters on a planet. So brain corals, in terms of the ocean, are some of the builders of the coral reefs that are now in varying parts of the globe and the world's oceans at risk due to climate change and other environmental issues due to human impact. These animals are really amazing because, as I said, they're builders, and so they're like the foundations of any house that you're going to build to sustain the reef. And a lot of animals live within those crevices. So what you're looking at is actually a skeleton of a coral, because when it's alive, it will have, you know, like a fleshy coating over it, have lots of feeding organisms or mouths called polyps that help the coral to live. But this is showing a skeleton. A lot of us scientists actually identify the different species of coral due to the exposure of the coral, if it's died off on the reef or bleached, and it's exposing this calcium carbonate skeletal features here. But as you can see, that's why it's called a brain coral, because it's showing those tracks sort of similar to our brains. And this is another one. And again, you could see that it looks very crater-like. So this is Gonistria, another form of builder coral. And within, so all those circular craters there, and they're really beautiful if you examine even more deeply in. So each coral's corallite, so all those circles or craters that you can see there are known as corallite. And their specific patterns give a scientist an idea of what species that they are. And we often, even though we talk about bleaching corals on the reef, but we often do then bleach a dead coral itself to get rid of all those dark bits that you can see. So that's the organic matter. But having said that, the organic matter is now proving to be very useful in terms of DNA or molecular analysis to know what this coral is telling us about the ocean that it once came with. So we might bleach half of a coral to expose the skeletons a bit more to identify the species, but then keep the other half with this dark matter, because technology is moving on so fast that we could analyze, you know, what bacteria was living, you know, what algae, what other exposures in terms of pollutants and pollution in the environment that the coral once lived. So that's really important to us now and in the future. I don't think when the Victorians were collecting a lot of this material, they would have thought about all of the tech that we would have now to analyze, to understand what's going on in the corals world. This is a branching coral, and it's known as Acropora. So it's very cosmopolitan, lives throughout the world's oceans. Again, all the corals have their own forms and function in the ocean. But this is very important because it's a branching one, and it allows protection for young fish and for adult fish to care for their young, escape from predators. But also it is revealing for us as human beings that the tips of those corals produce a substance that is similar to sunscreen. And so analyzing that chemical and perhaps reproducing that synthetically for our own protection here on Earth from the exposure to the UV rays from the sun, then this coral is really important to us and to other animals. And I must say, in terms of corals and coral reefs, that they are really important in terms of the Earth and the oceans and islands landmass, because we talk about the Great Barrier Reef, and it's not called the Great Barrier Reef for nothing, because the coral reefs form a barrier to the islands to protect them from tsunamis, extreme weather, ocean waves. And also the coral reefs themselves are biodiversity hotspots for different kinds of fishes that feed other animals higher up in the food chain, but also for us, for those of us that do eat fish, that we wouldn't have the diversity of fishes as a food source if these corals actually, you know, if we lose them on this planet, essentially, if they all die off. This is known as a boomerang coral because of the shape of a boomerang. so often there are scientific names for all of these. I must say, corals are animals as well. um, so there are scientific names, but to allow for accessibility when you're talking about these things to a public audience, so we often use more accessible naming. So the shape or form or the color of something. So the shape of a boomerang or a tongue coral as well. And the other corals that I showed you are colonial or many animals in one. This is known as a solitary coral. And that line running through is like the mouth of so it lives on its own. And there's another one called a mushroom coral. So people have historically had these corals lying at the bottom of their fish tanks, but corals are protected species globally across the world. So there's a lot of legislation in terms of having them or growing them, legislation to protect the areas where they exist across the world because they are very important to us and other animals. I've just got this pretty picture in there. Let's move on. So not many corals when they're bleached because of environmental issues or well when they die naturally, they don't have any color. They all look, a shade of beige or extreme white. This is even though the skeleton is hard in life or in the scientific grouping, it's a soft coral. And it's really interesting because again, it looks very crater-like, like some, planet there down in the space of the ocean. And this is called Tubipora musica. So I'm using the scientific name because musica, that last bit of its scientific name, which is known as the species name, gives an indication. Well, why would it be called? Can you play music on it? No, you can't, because when you cut this through the structure, and it's also known as the organ pipe coral. So it has all these tubes as part of its skeleton. I don't quite know why, and I've asked this question many times of why that when such a coral would die, that it doesn't, instantly turn white. It's something to do, and some of you may know better than me, but maybe in the art world and using pigment, that there's something to do with the red pigment that still remains in the, someone told me, in the architecture, in the body of the skeleton of the animal. That's why it remains red. And there is another coral, I don't have an image of it here and now, that is blue, that when you also slice through it, it's called Heliopora, or the blue coral, that is blue as well. Now, corals can tell us many things about the environment. So the same way that we're looking at outer space and selling satellites up and people, on board the spacecraft to do varying experiments to find out, well, is there life on Mars? Is there water? Those kind of things of the environments of those planets. The same way down in the deep dark oceans, corals can also tell us about the environment that they have existed in previously in the past and how they are coping with it now, how they're evolving to cope or how they're not evolving to cope with it. And I don't know if you can see here, and I can just about read it as well, but this is a coral and a slice through similar coral that is known as Porites vitea from Phuket in Thailand. And it was sliced through. It was actually collected by some colleagues of mine who were working on corals in that area in Thailand in the 1970s. And what it is showing that there's a red line throughout that coral, and that red band is iron, the iron salts from a factory. So this coral has grown in the environment and showing that at one point that there was an iron factory that was polluting those waters, and it has absorbed those pollutants. And I actually don't know if my colleagues actually collected this living or if it was actually found dead and then they collected it. I don't have that information, but it's just showing you that, the mining and, where things eventually, the deposits from mining or the industry, a factory, that the ions and various chemicals are absorbed by other animals that can be very detrimental to the environment and lots of other animals that coexist within the coral reef. Although I must say, even though we have to be aware of what we do while we're on this planet, not just thinking about, or wouldn't it be lovely to go to outer space, we do have to care about the planet and the environment that we currently live in, because we're all humans in this, natural world. But there are some animals, never underestimate tiny organisms in the world's oceans, but there are tiny things called amphipods that are probably like a millimeter to, well, the biggest one you might get is about 5 centimeters or something, that can actually utilize some of the toxic and heavy metals in our rivers and in our oceans. And there are many, many studies that are happening of trying to understand why, in comparison to their body size, that they don't die because of utilizing those ions that are there and those toxic heavy metals. So there's a lot of research still to be done and going on, but that doesn't take away from us as human beings to be aware of what we are doing every day when we exist, what we eat, what we buy, what we throw away, and where it ends up, whether we, in terms of recycling and so on and so forth, and where we deposit our rubbish and where it ultimately ends up. Now, you can see, I hope you can see this properly, it's very grainy because it is an underwater picture. So again, that these extremophiles, so there are a number of animals that live very, very deep in extreme environments. So this is like, these crabs look like they're walking over the crater of a planet, but in their deep ocean environment. And so there, as you can see here, it says that these are the Yeti crabs. So there are a few in the museum collections, but not many. And these are the Yeti crabs from this one, Antarctic hydrothermal vents. So hydrothermal vents were discovered in the 1970s. And these vents, for those of you who don't know, they are like volcanoes under the ocean, and they literally give off toxic water that is around 350 to 400 degrees centigrade. So it's so extreme that none of us can, and it's like, extreme environments in outer space as well. And we're constantly seeking, on what planet could human beings sort of live on and survive on? But down along amongst those hydrothermal vents are these crabs. And there are, I think the first new species of this crab was Kiwa hasuta, and it was nicknamed the abominable, like the abominable snowman, and a form of Yeti crab, because its extended first claws, I would say its arms, were extremely hairy. The image you're seeing now, is that the third species? No, I think that's the third species. But there's another species that has a hairy tummy, I would say, or chest. The underside of it, the abdomen, I would say as a scientist, but chest. Or that. Oh, someone okay? Someone's gone. Anyway, and so that crab is nicknamed as the Hoff. So for those of you that are old enough to remember Baywatch, there was David Hasselhoff, and he had a hairy chest running down the beach. But anyway, I digress. So these crabs just seem to have evolved with a lot of hair, either on their forearms or their chest or other parts of their body. And there's still a lot more to find out about them. But one of the reasons why they're so hairy is because they have chemosynthetic bacteria that lives amongst those hairs in order to them to survive that very hot, sulfurous, toxic to other animals environment. So those bacteria can utilize the sulfur in the water. So there's still so much to learn about those, but they're amazing. And they live in extremely big clumps together, huge masses amongst these volcanoes. This is another crab, a very smooth looking crab. So I've gone from one extreme to the other, very hairy to smooth. And this is Gandalf Cua. And the first name, Gandalf, well, is it Lord of the Rings? Have I got that correct? Those film buffs with Gandalf there. And so it's the New Zealand blind vent crab. And so a lot of again, this is an extremophile. It lives down amongst the other crabs amongst the hydrothermal vents, but is blind. And you get a lot of animals that live very, very deep that they are blind, and it purely because there is less light. But even though they're blind, they will have extended features. They've either grow very, very large and have very long arms or appendages. They'll be very hairy, or they will have long antennae to use that to get around for other sensory organs, essentially. So this is really and in terms of the species vulnerable list, so this is quite very vulnerable and extremely uncommon to find one. And obviously I would want these animals to still be staying in their environment. But then as a scientist, it's still good to know about these species and these animals, of how they exist, because essentially the more we learn from animals that live in these dark, deep, extreme environments, then for us as human beings, it might also help inform how we might potentially live, in places such as Jupiter or Saturn. Or there are other animals such as tardigrades. They're extremophiles as well, and they are near enough invisible to the human eye. But they have in the past, I think in 2007, were the first tardigrades or water bears. And you can search for those online because I don't have a picture of them. But they were actually sent to outer space as well. So a number of, extremophiles that live in ocean environments, or in terms of tardigrades, they can lay dormant for a while and then come alive for the slightest drop of water. Very, very interesting. Very much to learn. I've got this picture now of jellyfish because I also study jellyfish, but this isn't quite the jellyfish that I'm going to talk about, but we might discuss a bit later on, thinking about humans' mortality, but there are jellyfish. There is a species of jellyfish that is known as the immortal jellyfish as well. And I don't think they've taken any of those up to outer space and see how they might continue to live in that extreme environment. But the immortal jellyfish, Triratopsis dornii, it is as small as a pea, and it was an accident, but in the 1980s, it was discovered that in terms of its life cycle, it misses out a particular phase in the life cycle, and then can go back from being a mature adult and kind of reverse it consistently. And if anyone knows anything about jellyfish, they also have the ability to clone themselves as well. But there's still a lot to learn about such a tiny creature. That's what I said earlier. Never underestimate the very tiny creatures as well as, the larger ones, of how they are navigating their very extreme environments, or allowing their generations to exist forever. And as you well can imagine, there is to study these animals, such as the immortal jellyfish. Well, you have to, and I'm working on it, but living forever to do that research. So there is a scientist. Well, he retired in 2018. I only found that out towards the end of last year. A Japanese scientist called Shin Kubota, who spent nearly 30 to 40 years sort of studying this immortal jellyfish. And so his research needs to be passed on. I think there's a lab in Italy as well to continue that work, understanding why an animal like that can live so long. So I'm just going to kind of wrap up now, but and we're going to have, I think, I hope, an amazing conversation. But should I want to come back, or what I would want to look like and exist on another planet in the ocean or outer space, it's probably this amazing animal, which is a mantis shrimp. It has amazing coloration, and also in terms of the features of its eyes. So I'll just put that one out there. There's a lot to explain about this particular animal, but totally amazing. And I think I will leave it there. Then I'll put it there.
Fantastic. Thank you so much, Miranda. That was fascinating and such gorgeous images as well. I'm going to hand over to Louise now, who's going to chair this next part, I think for about 10 minutes or so, where we just have discussion between the three panelists, and then we'll open it up to the floor.
Thank you so much, Miranda. That was absolutely fascinating. And it's so interesting to think about how these creatures have evolved whilst everything else is happening in the universe over the history of Earth as well. I wanted to ask you both the same question, but Anik, maybe I'll start with you first. With your knowledge of how our planet came to be and all the life that has come before us and that we live amongst today, how do you feel about the changes that we're seeing in the environment and to Earth's biodiversity?
Yeah, in one word, sad. Yeah, it's for one, I believe the changes to biodiversity we see on Earth, like the usual timescales are over millions of years, if you will. But what we see currently is, as I understand, and what I see is we have done very well to compress it down to very uh, a short period of time, that said sarcastically, so to decade or hundreds of years, and this doesn't allow for biodiversity to adapt, as Miranda can say. Yeah, and I feel like it's not just, that we might have the possibility that a species might die off, but also like the relationships we have between different species, we will be losing that. So those interdependencies and such, I feel that yeah, we might lose that, and that makes me feel a bit sad. Oh, quite sad. Yeah. Mm.
Yeah.
Thank you, Anik. Miranda, would you like to answer the same question? Would you like me to repeat it?
And I can answer the same question because I definitely agree with Anik. And that's why I, in this in my talk mentioned the corals, because that is greatly impacted by what's going on in terms of us as human beings, and seeing biodiversity loss, because the the time scale of the rapid, well, we're in a planetary emergency. There's no doubt about that. That's what we're in. And there is hardly any time for species recovery. And I look at it and I think, well, in some parts of the globe, in terms of corals, is it that we make do with less biodiversity, but there is something, because there are some corals, like I showed you the acropora and staghorn or branching coral, and that's cosmopolitan. So that's amongst near enough all the reefs across the world. There are some corals that are specific in certain areas of the world, and we are seeing that though acropora is evolving to have some resilience. So when the other species die off, it may take 20 years or more for acropora to re-emerge. But we're just going to have that one species in certain areas of the world. So But I'm not to say, even though there are some that are becoming resilient in some areas, parts of the world, it's not to say that we shouldn't still be mindful as human beings that we want to keep the diversity, because there are then some other animals that are associated with the reef that need specific corals. So, but it is a worrying state in many ways. But as we all know, there are many great conservation trusts, and there's some great work actually coming out of a small museum in London with Jamie Craggs. I don't know if anyone has heard of him or knows him. That's doing great coral reef work at a small museum in London, the Horniman Museum, and looking at coral spawning, because coral spawning also, and that happens if the environment is right, but it is linked to the moon as well, and happening once a year. And you see this great, all these young ones of corals just coming out of all the branching corals, and that's quite amazing. But looking at how that is affected, and rearing corals as well, many different techniques of rearing corals to then plant them across the world's oceans. So yeah, we keep going.
I think it's really interesting to think about your knowledge bases, and also, everything else that everybody else here will have read and thought about and possibly experienced with climate change. Like, what is it that stops us falling into a heap? And for me, when I read about it, I feel extremely sad and devastated about what I'm seeing outside my window and everything else that I'm hearing about that's happening currently around the world and predictions for the future. But it's things like encountering any kind of insect, plant, animal outside, or seeing that photograph of that, I think it was a little crab that you showed, Miranda, and just thinking about that individual's experience of life. That's what it makes me feel determined to not fall into a heap, and to continue to try and share this perspective of thinking about the how cosmically special each individual creature and species is. I wonder if, Miranda, you'd like to say anything about what inspires you to kind of think about good things about it.
Yes, well, one thing on a daily basis is when I walk into the museum every day, and they've hung a whale skeleton. Sadly, in some respects, but this whale, it's called Hope. It's a young female blue whale that was beached, I think, in 1912 off the west coast of Ireland. But the whole point of that, and that's why the Diplodocus was removed, so Dippy, because we wanted to highlight and pay attention to what is going on in the world. We don't want to lose these species, such as the whale, and for them to become extinct. So that's one thing. Hope gives me hope every day. I'm also very inspired by the people that I meet, that I know that there are many individuals like me that care. So I can meet them on a daily basis. That keeps me going and working with them. And essentially what my role is. So I don't go, and this is my ethical standpoint. So I do not go on field work to collect more animals again for museums collections, because let's face it, I've got a lot of backlog because of Victorians, undescribed species, and so on and so forth. But I'm an advocate for using those historical collections for current research to protect, to develop conservation policies, for people to do molecular sequencing of some of the corals, as I mentioned, and take tissue samples from others. To actually, in the museum, we have in some cases for certain animal groups 80 years worth of environmental data, not just the animals, but the data of where they were from in the world. And so you could then use that to inform the living live research and create more marine protected areas, no take zones, where you in situ you just are analysing, doing the observation. And now the technology is amazing. So some of my colleagues that do go on scientific expeditions put down very sensitive camera gear now to send back images. In fact, I have two colleagues that are out in the Caribbean at the moment. So that all of that inspires me, keeps me going, feeds my mind. I'm very curious about a lot of things. And from what I can see from the museum collections and video footage that comes back live to me, is that the world is amazing. Outer space is amazing. And we have to, what do we want for future generations? We want them to also see how amazing it is and to understand how, the world's ecosystem exists, how we exist as human beings within communities. So those animals, those plants within their communities that are established, and we want to sustain that as well.
Mm-hmm. Absolutely. Yeah, I do feel like the sense of possibility is passed from one person to the other as you meet inspiring people who also deeply care about the environment. I think that's exactly right, and who are working in a way to better it in some way. That fills me with like joy as well, and that's why I really love bringing you both together for this talk. And
Louise, can I just say one thing as well? What also inspires me is artists like yourself. I love working with artists because that is also a way to inspire people. So let's not forget that. I will shut up now.
Thank you so much. Yes, I think it's so important to work in the method that suits you best to communicate the wonder of our world, and whether that's through being an astronomer, a curator of crustacea, or an artist, or just talking to your friends and family about how you experience the world and how important it is to protect everything. Anik, I wonder if you had anything to say about what makes, without feeling like we need to diminish the feelings of sadness or worry or anxiety for the future, which, for me, that's something that I live with every single day. But amongst all of that, when you look out into the night sky and you think about our planet, what is it that makes you feel good about or inspired to continue, sharing your knowledge with the world?
Yeah, so I think when I look, I think this has answer which has maybe matured over time. When I was young and I was looking at the night sky, I just looked at the sky and it was just amazing to see stars, um, and then when I started studying about them, and I got to understand how what they were, about stars, about galaxies, and so on and so forth. I think it just increased the beauty of what is out there, and it makes me then feel about Earth in like looking back that we are even here now to even comprehend this. We can even uh, we have experience, and we have with all our stories that we find ourselves here today. Um, but then, yeah, we can even try to comprehend and understand the Earth, the universe, and just life all around us. I think that's yeah, I think it's magical in some way or the other, yeah. So that we yeah, so I think for me this this like triumphs any feeling of sadness on that front, honestly, that we can uh, even live to do this, yeah. Hmm.
I completely agree with that. I think when I look into a beautiful night sky, I'm thinking about how overwhelming and with magnificence and beauty it is, and understanding that everything on Earth, was created in the universe, and that this part of the universe is also outer space. And yeah, that we have built up this knowledge to be able to unravel these mysteries of the universe and the earth and the deep ocean and everything. I find that completely exhilarating, the pursuit of knowledge of humanity to like absorb and reflect on the materials that we are made of the cosmos as well. And that, and considering the sort of plight of all the individual species that exist all around us, is those two things coming together is totally magic, and that's what makes me feel so determined and activated to keep going.
I think that sounds like the perfect time to end that segment. It always needs a bit of magic in there. So we'll open up the floor to questions. If anyone has anything they want to ask, you're very welcome to unmute yourself. Sam, we've just seen you've raised your hand if you want to go first.
Hi everyone. Yeah, just a bit of feedback in terms of everything that's been presented. I just feel like it was such an engaging, well presented, segment from Louise, from Anik, from Miranda. Louise, I loved the creativity of the imagery in the way that you were describing your journey in your project and all the work and how it's all intertwined, and just your very sort of like personal journey through it all, and what it means to you. And Anik, I feel like the science and the visuals that you presented as well, it just allows everybody to like contextualize just everything. So, the fact that, the skies and the cosmos, it's literally an entire world in itself, and it's just so breathtaking when you put it all into perspective. I think it's great. And I think Miranda, the comparisons that you put forward between the cosmos and the sea, and it's just fascinating to have that sort of contrast. And I think just in terms of a bit of sort of background, I invigilated Louise's exhibit just last week, and I feel like the atmosphere of the gallery in itself is great. It's a gallery that I got involved with when I started my work in local government. I initially started off in regeneration, so there was a lot around sort of sustainable environment, climate change, sort of biodiversity. So it was fascinating, the discussion and the strategy around that. But yeah, I just want to say, if you've not yet been down to Louise's little exhibit, please do bob down. Fantastic atmosphere. There's so much to take in. It's so immersive. It's fantastic. And yeah, I look forward to the Sounds of Earth event in Todmorden in March. And yeah, I've actually got a little question for Miranda as well, please. So the question is, it's news to me that corals are basically animals.
Yes.
So I was wanting to ask, is there some sort of scientific definition or criterion that sort of differentiates an animal from a plant? Because I always thought it was a plant. So is there anything to say exhibit A here is an animal scientifically and exhibit B is a plant? Thank you.
Yeah, well, the Victorians thought, they thought a lot of things were plants when they were animals, or that, anyway, I also work on barnacles. There's something called the gooseneck barnacle. They thought they were laid by geese. But yeah, there's a lot of actually myths or kind of like stories, narratives around that. But in terms of corals, and what I usually tell the kids, is that so corals are relations or cousins of jellyfish and sea anemones. So and they're animals too, probably a little bit more obvious, but they don't. All these things, it's always difficult if you don't see things like crabs with eyes and legs. So it's around the layers, the different layers that corals have. But all those little craters that I was showing you on them, so when a coral is alive, it basically has like a mini sea anemone that pops out of all of those. So it's a fleshy organism that has tentacles on, and they have different levels of stinging cells. But they're like mini mouths on each coral. It's not the easiest thing to explain in layman's terms without lots of visuals, because each coral has its different thing. Well, a little bit like jellyfish too, but somebody's got to study them. But they do have mouths, feeding mouths. So I always say these projections coming out of the corals when they're living are mini sea anemones, although they're not called sea anemones, they're called polyps. But they're cousins of everything.
Wow.
The corals are cousins of the jellyfish and cousins of sea anemones that you see in your rock pools and on the coast.
Wow. So every day is a school day then, basically, because I've always just considered them to be like fancy little plants. You wouldn't have thought that they were actually animals. So, well, thank you for your response.
And also, if you think about it as well, when they die off, what I showed you was the hard exoskeleton.
Yeah.
So with a lot of plants, you wouldn't get that. You might get a bit of woody vegetation, but yeah, you wouldn't get that.
Fascinating. Thank you.
Thank you. Has anybody else got any questions? You're very welcome to just unmute yourself or use the raise hand function. Yes, go ahead, Olivia.
Hi. Thank you so much. Really good to see you all. Louise, I wanted actually to hear a little bit more about the questions, or rather the answers to the questions you asked to the astronomers and the public on like where they could reflect to it. And so background to that is, I guess, listening to your 3 talks, I realized how much my own knowledge bases impacts how I relate to the topics emotionally. So, as an astronomer who works in a similar field as Anik, listening to his talk, you know, I switched off a little bit because not that I'm indifferent, but at some level, because it's my job, it is also a kind of tick boxing thing. Whereas when you then ask the beautiful, thought-provoking questions afterwards, that helped me really to get out of that headspace and back into the one I had before it became a job. And as an artist, because I'm both astronomer and artist, I am very much in that asking questions and exploring space in my head already. And so kind of back to feeling that awe and wondering towards space and the universe. Yeah, so when I then hear about a topic I know very little about, like Miranda's talk, I'm immediately in that headspace of, oh, wow, I don't know anything about this. So what have you found out in this participatory aspect of your exhibition? What's the difference between these 2 kind of groups that you asked? Was there something similar to what I just said, or did it surprise you? What did you find?
Hello, Ori. Thank you very much for your question. I think that's a really interesting thing to think about, because I've had lots of different conversations with different types of scientists, and also with the public who are non-scientists as well. And I think sometimes it was so the conversations I would have would often be a couple of hours. And it would initially start as almost kind of trying to chip away at somebody, trying to get in to invite somebody, one of the scientists, to think more broadly about their specialism and how that fits within this idea of like the cosmic wonder of our planet. And through the conversations, and it was often almost the same experience, there'd be quite a lot of hesitation to start with. Not everybody, like for example, Anik and Miranda, I didn't have that experience at all. But there's sort of like a hesitation to step outside of maybe that feeling of this is your job and this is your subject, and you don't have the same wonder for it that you might have had before you started studying or working in it. But then through our conversations, it would feel to me like the person would become much more receptive and think much more broadly about how their subject fits into this grand scheme of things of what we were talking about, and then later sort of talking about how they feel about how that relates to what we're all experiencing with the climate crisis. And so, yeah, there was elements of kind of distrust at the beginning sometimes. A lot of people thinking that I maybe don't have like that much knowledge about particular areas. And then realizing that maybe my knowledge is slightly more developed than they initially thought, and then they would become more receptive as well. So with different types of scientists. And I've also noticed quite different sort of connections to different timescales with the different scientists. So a lot of the biologists that I've spoken to, or people working with ocean biology, but I'm thinking particularly about in New Zealand. The scientists that I worked with there were deeply sad and anxious and scared about the developments that they were seeing. And then the geologists had a different sort of, so the biologists were perhaps thinking more about chains of life, I guess, all interwoven and interconnected. And then the geologists seem to have a much broader view of the time span and thinking about how things will eventually regenerate into something else. We're quite matter-of-factly kind of suggesting that this is the phasing out of humanity, and eventually we will move on to Earth will move on to something else without humanity. And then the astronomers were, again, a different story. A lot of people had a sort of, that I spoke to, had like a pathway into stepping back and seeing this like magic of the universe. But not everybody has, even if you're an astronomer, which I find really interesting. But I think what I hope to do through our conversations is to try and offer a conversation to draw people step outside of their specific subject and see it in the wonder of the context of the universe. And then working with different groups of people has just been truly amazing. So I worked in New Zealand with different high school groups, and then over in Halifax, I worked with people who had a connection to everybody arts, who were interested in using different materials to express themselves, so through drawing and writing as well. And what I've been really surprised with throughout every interaction is how willing people are to really share what they feel, or this is what they suggest, without kind of seemingly without sort of self-editing, and really making this connection of how much they care for the world that we live on. And how, again, this sort of feeling of perhaps of wonder for the universe trumps the feeling, sorry, bad use of phrase there, overwhelms the feelings of sadness and anxiety. There seems to be something in everybody who participated, that there is this openness to feeling and connecting with that, just exhilaration of understanding how wonderful Earth is.
Really beautiful to collect those and make them part of your exhibition. As you showed, you put up those letters. That's really valuable. And if you don't do that yet at Everybody Arts, I don't know if I understood whether that's part of the current exhibition as well.
Yes, yeah.
So people, audience members can also participate and write down. Yeah, beautiful.
Yeah. So people can visit the exhibition and take a postcard away, and then hopefully they will do their perspective whilst looking into the night sky and thinking about our place in the universe. and then return the card to everybody else, and it will be put on the wall. But yeah, I'm hoping to continue to collect these, and also I've been collecting voice notes as well from different scientists around the world, and it was just stunning to hear people sitting out under the stars and reflecting on, their field or their expertise and their feelings at the same time and sharing it through just a short voice note. So yeah, I would love your response to Ori. But yeah, I'm hoping to open it out and collect many more scientist responses and artists and non-scientists as well. So yeah, if anybody would like to, please get in touch.
Thank you.
Yes, Pauline.
Hi, Louise.
Hi, Pauline.
Hi. Big admirer of your work, as you know, for a long time. But it's just very quickly to say, the power of creativity, bringing the science and the arts together, and how much can be done within these conversations, and bringing the public in, and kind of doing more of this. It does kind of resonate with people, and people start to see things in different ways, and it just expands things. So I think it's the creativity and the science is just a really valuable thing.
Thank you, Pauline. And Pauline and I have had some wonderful conversations about how we interact with the cosmos and how important it is to both of us. So thanks for being here, Pauline, and contributing.
Oh, thank you. Finn.
Thank you for such interesting talks. I've got a question about audio for all of you. Louise, you mentioned that audio is important in your exhibition. And for Miranda, is it true that you can play the sounds of healthy coral reefs under the sea to coral and it helps regenerate it? And if so, how and why does that work? And Anik, is sound important in studying the universe?
Thanks, Finn, for that question. Yes, I've heard that. When you're talking about audio. It seems to be true. I'm not doing in-depth study on it, but as I mentioned, Jamie, who works at the Horniman Museum, is. So I usually, well, I haven't collected. I just know Jamie and follow his research. But I haven't worked with him actively, so I'm just following what he's doing. I haven't had a full-on conversation with him about it, but I've seen reports through his work that is the case. But I would look at it, and I can't even remember, so apologies, of what species of coral, because it would be quite, I'm sure from what I read, it's quite specific. I don't know what you've seen, so it might not work for every coral. Yeah. But yes, I do know about it, but not as in depth. So note to self to contact Jamie and find out a little bit more. And it's good though that kind of thing is being looked at, because there's always a lot around. Well, obviously, audio bird song, we know that, and the rising movement of listening in terms of trees as well. The audio of how they uptake water and that sound, but where I work at the moment, they are centering on insects and audio as well there. But yeah, Jamie's the one. But I've just made a note to myself. So good question, but sorry, I couldn't answer it fully. Yeah.
Thank you.
May I just take that? Thanks for the question. And actually, yeah, and one of the immediate examples also relevant for this this cosmic timeline that we were talking about, there where we actually see the impact of sound waves, is the cosmic microwave background the picture that I showed you, this where you saw the little patterns of red and blue all over. And that's actually because before the first atoms formed, the photons and all the particles, they were all coupled together into like a dense plasma, and until it decoupled, so there were sound waves in this plasma, and the patterns, the size of the patterns that you see on the cosmic microwave background was how fast sound waves could travel till photons decouple from the atoms, if you will. And so we actually see the immediate impact of sound waves in the very early universe that we can see today, because the photons after that from those potential wells just came towards us, and those potential wells were shaped the size of them by sound waves. Yeah.
Wow. Thank you.
And Louise, do you want to talk about sound?
Oh, yes. Finn, did you have a question about the sound specifically?
Well, I was just wondering if you'd noticed these links between the sea and the universe and sound, and you mentioned that it was a kind of process of collage, a bit like with the images over time. And how do you obtain it? Do you take field recorders out and microphones and?
Yes, that's right, exactly. So I spend a lot of time. So with each sort of project or residency that I do, I always start by visiting a place and taking a camera and different microphones to spend time in the place, hopefully first, and then do a lot of field recording of different aspects of the soundscape in the day and at night time. And also use things like contact mics to listen to the sounds of movement within the trees, and different microphones to gather different sort of layers of sound that are then added together and manipulated so they don't sound exactly sort of familiar to what you're thinking about, to what you might be familiar with. They might sound almost the same, but kind of like, again, creating this idea of distance within the sound. And I have always thought that sound is really, it's really important to include it in the way that I exhibit work as well, because I want it to be more of a multi-sensory experiential experience, but also because sound has been such a transformative thing for me for thinking about the experience of other life on Earth. So I've mentioned this probably to Sammy and Lauren before, but many years ago, I went with my partner to Calderdale Forest, and this was the first time I'd listened through different microphones to different aspects of the environment. And we listened to water moving through moss, and it was absolutely incredible. It was one of those profoundly moving experiences, like I mentioned before, about encountering these sheep, Herdwick sheep under the night sky. And I just believe that sound can communicate so much that's not through sort of vision or text as well. I think it can tell you a million things in a sort of really short space of time and allow your mind to be open to reflection in the same time. So I think sound is really powerful medium. And one other project that I worked on with my partner John and my collective super collider was using sound. The project was called Biodiverse Earth, and the sound that we used was from a scientist in Costa Rica, and she had put all these different microphones within different plantations, so in teak and sustainable teak and palm plantations in Costa Rica. They were audio moths, so like attached to trees and left for a long time. And also in the undeveloped forest, the forest that was more considered more natural. And what you could hear within 10 seconds of listening to the different soundscapes was extraordinary. One was full of biodiversity, the most incredible types of birds and monkeys and insects that you can imagine in Costa Rica. And then the plantations were just crickets. And it was, again, as I say, you could tell 1,000 different things just in a few moments of a soundscape. So I think it's a really powerful medium. And yeah, and also the experience of listening when you're recording is truly amazing, and a different way of experiencing the environment. It feels, I've spoken a lot before about how it feels like peering through a keyhole or through a window into the experience of other life forms that we're not usually invited into. It feels very very special to kind of have that technology to be able to see into the world, which is one of the other really profound experiences of encounters with things in the world was when I was a young person. I went snorkeling for the first time and saw fish in a tropical sea, fish a bit like your beautiful picture, Miranda. And that was, again, like looking through a keyhole or a window into another world where we are having an impact on that we don't feel sort of part of. And yeah, I think that's what sound can do as well.
Thank you.
Thank you. Lawrence, go to you.
Yeah, just as many of us are artists here, I just thought it would be interesting to hear Anik and Miranda just about your experience or your way of how the creative process takes place within your work, as my internet connection just buffered. Yeah.
So sorry, Laura, was it excuse me. Was your question about how does the creative process work for me?
Within your
working with art?
within your practices, yeah.
Oh, in many different ways. I just invite artists in. Whatever. That's what I love about it. And I suppose, Louise, that's why, I was open to this. I'm just one of those scientists that are because as I've told you, I think I've told you the story that my mum said I would never make any money as an artist. So I went the science route and then, get my true passion in through the back door. So there is no scripted or creative process for me. You know what? I just invite artists in. I just show them what I've got, what I've got access to. We do a walk and talk. They reignite my enthusiasm for what I do, because I think someone was mentioning earlier, that you can, if someone's talking about your own subject, you can sort of switch off, and then somebody else talks about something different, you go, oh, and then it's not often you then put both of them together and see where the common ground is or where the differences are to spark off on top of that as well. But when I invite art and work with artists in many different media, from fashion designers, photographers, all sorts, painters, even down to different animals have different chemical chemistry in their blood or their bodies, and then using pigments, paints that have those similar properties to create the artwork as well. I find that fascinating. But when I show artists stuff, as I say, specimens, objects, it sparks that conversation of how they're seeing it, and they see something different in that animal. Or sometimes I show plants because I have a side interest in plants as well, as one should do as well. But it's like, oh, I was probably just seeing it with my scientific lens. And hang on a minute, an artist comes along and sees something different. and then I really get into it. It's like and what I'm reflecting on is actually working with a fashion designer, um, who I showed her beader and a textilist or something. Anyway, these two other colleagues that she had with her, the corals, and then I was seeing other colors within corals that I thought were just white. So when I showed you the organic matter, that was quite dark, but there are some some corals that have subtle colors of purples and blues and greens, and then you're seeing like a whole other like technicolor world that you were blinded to from everyday work. So that's what I love. So each creative process is different, and that's what I love about it, and it keeps me going. But it's not every scientist's cup of tea, but it's my cup of tea, because I want other people to be inspired by that, to understand why they should care about any and everything, and that there's scope on a lot of things as well to make a difference.
I'm
Yeah.
aware that we're running out of time now, but Anik, did you want to talk about creativity in your practice before we
Oh,
end?
maybe I'll just try to keep this short then. Yeah, I think I'll just first say what Miranda said also resonates a lot for me. And one thing about the whole scientific enterprise is that, we can be creative with the theories we come up with, but then we are heavily constrained. I mean, in the end, it's the data we have to explain. So I think it's so we have to make sure that we whatever theories we make, they in the end they can explain the data that we or the observations we make uh, out there in the sky, and then and try to possibly predict for new observations to follow that up and see whether that matches or not. So I think it so from on that front, creativity would be in this constrained landscape, how we can think about what the laws of the universe are. Yeah.
Thank you, Anik. Right, we'll hold it there for questions. Apologies for anyone who had anything else burning they wanted to ask. If there's anything desperate, you can always pop an email, and we'll always try and pass your question on to the relevant person. Thank you all so much for joining us tonight. It's been an absolute pleasure. It's been so lovely as well. Thank you to all of our speakers, really taking us between these very small moments to these really great big expanses and linking everything together so well. Louise, it's been such a well curated discussion to have those three of you together. It's been really lovely seeing the parallels across all three. I hope you've enjoyed it. It's something we've very much been looking forward to and really enjoyed as well. As Louise mentioned, her exhibition is on until the 7th of March. It's open Wednesdays to Saturdays, 1 till 4 p.m. Please do make time to pop down if you haven't already. It's a deceptively massive gallery, so there is plenty to look at. And please do contribute your own postcard to the long walls of them. There's honestly, do take the time to have a read. One of the things when we were curating the exhibition was that we really wanted to make sure we had that space for people to contribute and to have all of those voices alongside these gorgeous massive prints of Louise's work. So do take the time to read and really reflect and think about this wonder, this magic that we've been talking about, as much as the challenges. One last shout out that I do as well is that Louise does have this upcoming workshop. It's a sound workshop on the 7th of March over in Todmorden. Details are on our website, and I'm sure will be sent out to you after this as well. But please do take a look. It'd be lovely to see you there. And again, thank you so much for coming, and enjoy the rest of your evening. Hopefully we'll see you soon, everybody else.